In example 1, we're going to talk about the three functions that we've studied so far this year. The first one being linear functions, and we did that first semester. The equation for a linear function indicates that the variable is only raised to the first power. Here are some examples of linear equations. We have y equal to 3 times x minus 5. Notice that the x is only raised to that first power. In the second one, negative 2x plus 7y is equal to 10. If we solve this for y, again, the x is only raised to the first power. And then the same thing, x equals 2, that's just our vertical line that we have. The graph of a linear function is always a straight line, so it could be on the diagonal in either directions. It could be horizontal or it could be vertical. And then if we look at a table of values with our linear functions have something what we call a common first difference. So as we look for that common first difference, it has to be with consecutive terms. Consecutive being one after the other. So 1 to 2 is consecutive terms, 2 and 3 are consecutive terms, 3 and 4. And so what we want to do to find that common difference is you're always starting at the bottom of the table and working your way up. And so what we do is we would subtract 16 minus 13 is equal to 3. If I took 13 minus 10, I also get 3. And if I take 10 minus 7, again I get 3. So that 3 is what we call a common first difference, difference being subtraction. Next, we also studied exponential functions. If we take a look at our exponential functions, our equations tell us that the number or the base is raised to the x power. So we have something raised to the x. That indicates that exponent there that it is going to be an exponential function. Here's an example. So y equals 3 to the x. This is also an example of an exponential function. Notice the 1/4 is our base being raised to a variable of x and then minus 2. The graph of our exponential function, if it's a growth function, we have a curve that rises from left to right. And if it's decay, it's going to descend from left to right. If we take a look at a table of values with our exponential functions, again, they have to be in consecutive order, and they have what we call a common ratio. Ratio means that we're looking at division. So just like in the linear table, we're going to start from the bottom, and we can divide our way up. So we would look at 27 divided by 9, which is 3. 9 divided by 3, which gives us 3. And 3 divided by 1, which also gives us 3. This 3 is what we call a common ratio. And the last function that we've studied so far this year is the quadratic function. Our quadratic functions, in terms of our equation, means that the highest exponent that we have is a 2. So if we look here, we have y equals 3x squared. That squared term indicates that it's quadratic because there's no other exponent that's bigger than that. And down here we have x squared minus 3x plus 8. And again, that 2, that exponent is the biggest exponent we have, telling us that it's going to be a quadratic function. The graph of a quadratic is a parabola, so it can open up or it can open down. In our table here, to indicate whether this is a quadratic function, we are looking for what we call a common second difference. So linear is a common first difference, quadratic is a common second difference. So what's going to happen is you're going to again subtract, starting from the bottom, going up. We would get 11 minus 6, which will give us 5. 6 minus 3, which gives us 3. 3 minus 2 gives us 1. And then we look at the second difference. So now we subtract again. And we get 5 minus 3. So we're looking at these two, which gives us 2. 3 minus 1, which also gives us 2. And that 2 is what we call a common second difference. We're going to use this information to help us identify functions from equations, graphs, and tables as we go through this next unit. If you have any questions about any of the functions, let me know. Otherwise, you can move on to example 2.